Assalamualaikum warahmatullahi wabarakatuh. My name is Fazrin bin Inas. I am a fourth year student from FTK. So today I'll present about my title, Engineering Properties of Soil Randomly Reinforced with Coated Bamboo Fiber for Road Subbase. As we all know, soil reinforcement is required to overcome the issue of inappropriate soil for building roads. So for soil improvement approach is the use of natural fiber as a soil reinforcing material. However, natural fiber is usually have hydrophilic nature, which allow it to absorb more moisture and when it absorb more water, it will cause the properties of the fiber to become lower from its original properties. So to overcome this, my type to overcome this, we have to coat the natural fiber with water repellent chemicals such as epoxy resin. So in this project, I will use epoxy resin to coat my bamboo fiber for soil reinforcement of road subbase. So the purpose of this research is to look onto the efficacy of coated bamboo fiber as soil reinforcement for road subbase. So to preserve its mechanical and physical qualities of the bamboo fiber will be coated with epoxy resin mixed with acetone. So the significance of this study will assist society by lowering the road maintenance cost and lowering the rate of traffic accident caused by damaged road. So there are 10 tests that included in this study. First of all is plastic limit, liquid limit, hydrometer, specific gravity, compaction, tensile strength, water absorption, density test, scanning electronic microscope (SEM), direct shear test, and CBR test. For the results, for the water absorption test, it can be seen that the 1:6 ratio of acetone and epoxy resin have the lowest water absorption compared to others such as uncoated bamboo fiber 1:4 and 1:5 mixed acetone epoxy solution. For the density test, it can be seen that the highest density of bamboo fiber is 1:6 coated ratio bamboo fiber, and the lowest of the density of bamboo fiber is the uncoated bamboo fiber, which is the raw bamboo fiber. For the SEM test, it can be seen that the 1:6 ratio acetone epoxy solution have coat more than other ratio. This is because the acetone, the high value of acetone ratio make uh make the epoxy easier to coat the bamboo fiber. For the liquid limit and plastic limit of this test, the value obtained is 65 for liquid limit and 39.02% for plastic limit. So the plasticity index for Atterberg limit test is 30.1. For the compaction test, it can be seen that as the content fiber increases, the optimum moisture content for the fiber also increase from 0 to 1.25%. But for the dry density, as the fiber content increase, the maximum dry density of the fiber content decrease. For the CBR test, it can be seen that the 1:6 ratio bamboo fiber, when it is penetrate with 2.5 mm and 5.0 mm, the reading goes higher than compared to other CBR samples. For the direct shear test, as the fiber content increase, the frictional angle also increase, but it stopped to increase until 0.5%, and then the frictional angle for the fiber content start to decrease starting from 0.75 to 1.25% of fiber content. As for the conclusion, the 1:6 ratio epoxy acetone coated bamboo fiber are able to penetrate the bamboo fiber better than other ratio such as 1:4 and 1:5 ratio. So if we see the SEM result, we can see that the 1:6 ratio able to penetrate the bamboo fiber more than other ratio. So this is because the low viscosity of the viscosity of solution that able to penetrate the bamboo fiber. Because of the more protective thin layer given by epoxy and acetone solution, 1:6 ratio bamboo fiber have less water absorption rate compared to other ratio. Mal,